Welcome to Lesson 7 of iptables Mastery. Up to this point, your firewall has been a bouncer. It allows packets in or it blocks them at the door. NAT is something fundamentally different. It rewrites them. A packet arrives for port 80 and quietly leaves for port 8080. 50 machines on your internal network step outside wearing the same public IP. This is how your home router works, how Docker exposes containers, how Kubernetes services route traffic, and how VPNs hide topology, all built on 3 verbs, DNAT, SNAT, and MASQUERADE. Here's the map for the next 40 minutes. 4 ideas, building on each other. First, why NAT exists at all, the IPv4 scarcity story that forced this whole mechanism into being. Second, DNAT, which rewrites where a packet is going and lives in pre-routing. That's your classic port forward. Third, SNAT and MASQUERADE, which rewrite where a packet came from and live in post-routing. That's your gateway hiding 50 machines behind one address. And fourth, the kernel switch everyone forgets, IP forward. Without it, none of the rest does anything. So let's start with the why. NAT exists because of 3 pressures that never really went away. First, IPv4 scarcity. 4.3 billion addresses for 8 billion people simply doesn't math out, so your home router crams every device behind a single public IP. Second, port forwarding. The Docker story, where traffic hitting port 80 on the outside needs to land on port 8080 inside a container. And third, a quiet bonus. From the internet, your 50 internal machines all look like one address, not a security boundary on its own, but a useful side effect. And here's that Docker story made literal. A packet arrives from some random client out on the internet, headed for your public IP on port 80. One DNAT rule in the NAT table's pre-routing chain, match D port 80, jump to DNAT, send it to 10.0.0.58080, and the kernel performs surgery on the headers in flight. Source IP and port, untouched. Destination IP and port, rewritten. Same packet, new address label. From there, it hits the forward chain and rides out to the internal machine, which has no idea any of this happened. Now flip the direction. Outbound traffic leaving your gateway needs its source rewritten too, and iptables gives you 2 targets for that job. SNAT hardcodes the public IP. Fast, explicit, perfect for a colo box or a cloud VM with a fixed address. MASQUERADE asks the outgoing interface what its IP is at packet time. Slightly slower, but it survives DHCP leases changing under you. Same chain, post-routing, same goal. Pick by whether your public IP is nailed down or moves around. Now let's stitch it all together for a packet that's just passing through. The classic router scenario. It hits pre-routing first, where DNAT rewrites the destination from your public IP to the internal box. Only then does the kernel make its routing decision, and because the destination is already internal, it correctly picks the LAN interface and sends the packet to forward. Filter rules decide if it's allowed, and finally, post-routing does SNAT or MASQUERADE on the way out. DNAT first, then routing, then SNAT. That order is why Docker, Kubernetes, and your home router all behave the way they do. With that order in mind, here's the actual recipe you'll reach for again and again. First, flip on IP forward. Without it, the kernel won't route between interfaces, no matter how clever your rules are. Second, the DNAT rule in pre-routing rewrites anything hitting ETH0 on port 80 to 10.0.0.5 on 8080. Third, explicitly accept that forwarded traffic in the forward chain because filter still gets the final say. 3 commands, and your public 80 now lands on an internal 8080. Now you might be wondering, if we rewrite the destination on the way in, why doesn't the reply come back looking weird to the client? 3 reasons. Contract remembers every translation it makes, so reply packets get automatically undNATed on the return trip. IP forward is off by default because forwarding turns your box into a router, and the kernel wants you to ask for that explicitly. And the chain placement isn't arbitrary. DNAT has to happen before routing so the kernel can pick the right interface, while SNAT happens after, once that interface is known. So here's your cheat sheet. Print this one. The left column tells you where each operation lives: DNAT in pre-routing, SNAT and MASQUERADE in post-routing, and forward when you're filtering traffic that's just passing through. The middle column is your verb reference: DNAT for port forwarding, SNAT when you have a static public IP, MASQUERADE when your IP is dynamic like a home connection, and redirect when you want to bounce traffic to a local port. And the right column? Those are the setup commands you will absolutely forget at 2 in the morning when nothing's working. Starting with ipforward, which is the single most common reason your NAT rules silently do nothing. Now it's your turn. 3 drills all inside your VM, each building on the last. Start by confirming IPI forward is actually on, 5 minutes, and it'll save you hours later. Then stand up a Python server on localhost and redirect port 80 traffic to it. That's a real port forward in miniature. And finally, watch Contract record the translation live so you can see the kernel remembering both sides of the rewrite. Read the hints. They're there because every one of these has a classic gotcha. Before you go off and build your own NAT setups, let's talk about the 5 mistakes that will eat your afternoon. They're all silent. No error, no warning, just packets vanishing. Forgetting IP forward, putting DNAT in the filter table, leaving forward set to drop, MASQUERADE on the wrong interface, or passing a host name to source. Every one of these has burned every engineer I know at least once. Memorize the fixes on the right. That column is the cheat sheet you'll come back to. And that's lesson 7. You've made the leap from filtering to rewriting. DNAT in pre-routing to pull traffic in, SNAT or MASQUERADE in post-routing to send it back out, IP forward enabled, and a forward chain that actually lets the packets through. Next up, lesson 8. Persistence and rollback. We'll cover iptables save, net filter persistent, and the dead man switch that keeps you from locking yourself out of your own server. See you there.